Hello subscribers and guests of the channel, welcome back. This is lecture 4, integration by parts. At the beginning of the lecture, however, we will also mention standard integrals because we'll need them in order to progress to integration by parts. And there will be also some jokes, so stay tuned. Please also feel free to write in the comments what you like in my course or what you don't, how in your opinion I can improve this experience. And let's begin. So, as usually my paint is prepared, so let's start dealing with integral, which can be not to say only, but in most cases, like the easiest way to solve it is integration by parts. So first of all, what is integration by parts? Integration by parts is used when you have a multiplication of two functions. For example, you have integral x sine x. So x is multiplied by sine x, dx of course. And in this case we cannot break this integral into two parts. We cannot say that it is integral of x and then times integral of sine x. It does not work that way. So what to do? The main formula for integration by parts looks not so difficult, however it constantly raises a lot of questions about how to use it. So integral of u v dash will be the same as uv minus integral of u dash v. So this is how the formula looks like. But many people don't understand what in this case is u, how to choose u, how to choose v, and how to approach these questions. But before we jump to integration by parts, we need to study some integrals of most common spread, trigonometric and other functions. From last lecture we know that integral of ax power n dx will be x power n plus 1, and then a will be divided by n plus 1 and then plus c. However, there are different functions in this world, so we need to know how to integrate some of most common. For example, you know that sine x dash, so derivative of sine x, will be cosine x. And you know that derivative of cosine x will be minus sine x. So therefore, if we want to take an integral of cosine x dx will be sine x plus c. And the integral of sine, because we know that cosine x dash will be minus sine, so then integral of sine will be minus cosine x. So integral of sine x dx will be minus cosine x. Another interesting function is e to the power x, because e to the power x dash is not changing and it stays the same as e to the power x. Therefore integral from e to the power x will be also e to the power x. So e to the power x will be the same e to the power x dx. And by the way, closer to the end of the lecture, I will tell you a small joke or an anecdote about this derivative and integral of e power x. So keep watching to the end and you'll have some laugh there. Now, while knowing the standard integrals of these three relatively simple functions, we can progress to integrating by parts. I will copy it from here downwards so that you can see the formula in front of your eyes. Here like that. And let's start. So this is multiplication. We need first to assign one part of the multiplication as u and another one as v dash. So we have two options. Either this can be u and sine x can be v dash, or alternatively this can be v dash and sin x will be u. So how to identify which is which and what to use as u and what to leave as v or v dash? So the answer is in fact relatively simple. When you have something which is easy to differentiate and which can either disappear after differentiation or which can become much easier after differentiation, you call it u. So for example, x derivative x dash will be 1 and sin x dash will be cosine x. So now think, what is simpler? If you differentiate x, you will get just 1. This is very simple. If you differentiate sine, well, then you get cosine x, which is not any simpler than sine. So here looks like the answer is obvious. Our x should be u. Sometimes, however, you should also pay attention to possibility of integrating v, because whatever you call v dash, in this case sin x, you'll have to integrate. If you call v dash a function that you cannot integrate on its own, then there is no point to call it v dash, because you will not be able to do anything with it. But here x is u and sin x is v dash. I would strongly advise you to write separately, so what is your u? U is x, at least at the beginning while you're not so confident in that. While you progress to the higher confidence levels, you may of course do it by head, like inside your head. So your u is x, then u dash will be 1. Then your v dash is sin x. In this case, your v will be integral of sin x, and the integral of sin x, as we have mentioned before, will be minus cos x. So it will be minus cos x. I'm not writing here plus c because here constant c is irrelevant. So let's now write the formula knowing what is v and what is u. In the formula we have first uv, so I can write that our integral of x sin x will be uv. U is x, but v is minus cos x. I can write minus in front of x, so minus x times cos x, and then minus integral already u dash, and u dash is 1, so 1 times v. What is v? V is minus cos x, minus cos x dx. Did it become simpler? Well, yes it did, because in this case we have to integrate only minus cos x, and if we take minus outside of the integral, it can be compensated with that minus in front of the integral. So I can rewrite it as minus x cos x plus integral of cos x dx. And the integral cos x is a much easier integral than x times something. So integral of cos x is just sin x plus c. So I can replace that as sin x, and my final answer will be minus x cos x plus sin x plus c. So that's our first and simple integral solved through integration by parts. And now let's check it. Let's make the differentiation back to see if we'll get what we are looking for or from what we've started. So minus x cos x dash plus sin x dash can be differentiated. This is from sine it becomes cos x, and that is a product rule. So I have to do minus x dash cos x plus minus x times cos x dash. If you don't know how to differentiate that, you should watch my videos on differentiation. They will be soon on the channel. So then minus x dash, it will be minus 1, so it will be minus cos x. Then minus x, and from cos I get sine, but I get minus sine, so here the sign will change to plus, sine x, and then plus cos x. Therefore cos can be simplified, it goes out, and the result is exactly x sine x. That's what we started from. It means that the integral was taken correctly. Congratulations! Now we will deal with two trickier integrals that can be done using integration by parts. The first integral, which is typically met, is integral of x squared e to the power x. And again the same rule applies here. How do we solve it? Well, we need to identify first what is u, what is v. E to the power x does not change, so it stays, its derivative and its integral is the same. So it doesn't matter, like it will not go away if we differentiate it. So e to the power x dash still is e to the power x, which doesn't help. But what about x squared? X squared dash becomes 2x. Although it has not helped us much yet, but it has a reduced power. And if we differentiate it again, so 2x dash again, we will get 2, which will allow us to get rid of x. So that's exactly how we are going to deal with this question. So this tells us that we can use x squared as u, we can take it as u, and e to the power x will be v dash. And again, let's write it down here. So u equals x squared, u dash will be 2x, v dash equals e to the power x, and v then is still e to the power x. With that said, we can continue. We have integral of x squared e to the power x, with this being u, this is v dash. The formula is still the same, which is uv minus integral u dash v. So what will be u? U will be x squared, e to the power x is v, minus integral, and then u dash is 2x, and v is e to the power x dx. Did it become simpler? Well, on the one hand not, because we still have a pretty difficult integral. On the other hand, yes, because now we have lower power. Let's take the constant outside and then repeat this thing again. So we can use the same method for the second time, solving the second integral. I will put it separately here. So integral x e to the power x can be solved using integration by parts, taking x as u and e to the power x as v dash. So we will have u equals x, u dash equals 1. E to the power x is v, and v dash is still e to the power x. So this integral can be written as uv, which is x e to the power x, but then minus integral of u dash, which is 1 times e to the power x dx. And that integral is already much easier because it's integral of e to the power x, and e to the power x integral is just e to the power x. Therefore, plus c. We can replace now that integral by this expression, and that integral in turn by this expression here. So solving it like a Russian matryoshka, we can arrive to the result. There is no more integration needed. We can just write it down that the final integral is e squared e to the power x minus 2, then in brackets x e to the power x minus e to the power x, and then plus c, bracket closed. Plus c I can actually put outside of the brackets completely, because if we multiply some constant by 2, we still get the constant. Since c is any number, it is not changing if you multiply it by any other constant. So finally we have to open the brackets. How do we open the brackets? Well, we need to multiply everything by minus 2, x squared e to the power x minus 2x e to the power x, and then minus 2, or actually plus already, because minus times minus gets us plus, and then 2 e to the power x plus c. And of course we can take e to the power x out, since it's present everywhere, and we get e to the power x in brackets, then x squared minus 2x plus 2, then plus c. That's the result for that integral. And we'll have one more interesting integral, which is quite tricky and puzzles a lot of my students. That next integral will be integral of ln x. ln x, just to refresh your memory, is log power e, or base e, sorry, not power, from x. So when you need to integrate ln x, at first many people get puzzled how to do it, what way or what method to use. The answer is integration by parts. How? And the trick is here that we cannot just like, we don't have here the second part. We do not know what is u, what is v. However, we can pretend that we do have the second part, and it is 1. So integral of 1 times ln x dx. Now the question arises, what is u, what is v? Well, if this is, for example, v or v dash, then we'll have to integrate ln x. But we don't know how to do it. That's exactly what we're trying to do. So it doesn't make sense to integrate that. And also, if you differentiate the constant, it will give us 0 and nothing good. So we want to approach it in a different way by calling 1 as v dash and ln x as u. And why is it beneficial? Because u dash in this case will be derivative of ln x, which is 1 over x, which is nice, while u is ln x. And then if v dash is 1, then v is relatively simple. It will be integral of 1 relative to dx, so it will be just x. And that's nice, because although here x will appear out of 1, which makes the things more complicated, but ln will disappear into 1 over x, which is much easier to deal with. Now let's put everything back into our formula. So it will be uv, which is x ln x, and then minus integral u dash v. so u dash will be 1 over x, and then times v, which is x dx. The nicest thing about it is that x and x in denominator will cancel out, they will simplify, so we'll have just integral of 1 dx, which is x. So the final answer to that seemingly complicated integral is simple: x ln x minus x plus c, and that's all. Now you know how to solve complicated and not so integrals using the method integration by parts. This is a very powerful method, so please use it, and a lot of tasks that seem too difficult for you as of now will seem much simpler for you in the future with this method. And now finally the joke. So the joke with e to the power x. A guy decides to come to work to a psychiatric mental hospital, and he asks the boss what to do. The boss says, oh, it's not difficult, you will put our patients to sleep. How? Oh, you just come to them and you tell them just go to bed, and they will go to bed. But what if not? Asks the guy. Oh, well, there is, for example, a room where are crazy mathematicians. They got a bit mad, they consider themselves as functions. So if they don't go to bed at once, you can threaten to differentiate them. Because when you're differentiating, the power is going down, and they are very afraid of that, and they're going to bed. Okay, said the guy, and came to the room. So, dear mathematicians, dear functions, go to bed, he said. The people did not move anywhere. Go to bed at once, now, otherwise I will start differentiating you, said the guy. And everyone got afraid and went to bed. And one is sitting. Don't you understand? I will differentiate you. Oh, I don't care, you can even integrate me. I'm e to the power x, said the guy. So that's one of my favorite mathematician or mathematical jokes. I hope it will make math a bit more fun to you. Thank you for watching, and see you at the next lecture, Integration by Substitution.